Okay, so as in the last video, we have solved the MCQs from the OETP book, which is for NUST past papers. Alright, so in today's video, we are going to solve the atomic structure MCQs from Ecat, as you can see here the topic. Alright, today we are going to solve the MCQs from Ecat book of chapter 2, or you can say maybe in your book that is chapter number 5, that is atomic structure. Alright, so let's start it what they are asking us in the first question. Alright, so wait, let me zoom in so that it can be visible, the questions can be visible to us. Alright, so it might be visible to you now. So let me choose the highlighter first. Let me go with it. Okay, so this is, I guess, fine. Okay, so first MCQ. The letters S, P, D and F are used to represent which quantum number? We have discussed 4 quantum numbers: the principal quantum number, azimuthal quantum number, which is also known as the angular momentum quantum number, or magnetic quantum number, and last but not the least, but spin quantum number. Alright, so principal quantum number tell us about the shells, while angular momentum or azimuthal quantum number tell us about the subshells, and S, P, D, F are the subshells, right? So angular momentum or azimuthal quantum number tell us about the subshells. Wait, let me choose a good color so that it can be visible to everyone. So we have azimuthal quantum number. Alright, what are they asking us in the second MCQ? The magnetic quantum number has its values limited directly by the value of principal quantum number, angular momentum quantum number, or azimuthal quantum number, spin quantum number, or both AB. We have already discussed that when n will be 1, or when n will be n will be 1, then azimuthal quantum number will be less than n. So angular momentum quantum number must be 0, and the magnetic quantum number will be from plus L to the minus L, which means it is contradictory, or it is derived from principal quantum number plus azimuthal quantum number, or it is derived from azimuthal quantum number and azimuthal quantum number is derived from principal quantum number. But yeah, here it is derived from both AB, because if it is derived from azimuthal quantum number, but azimuthal quantum number are itself derived from the principal quantum number. So our third MCQ, when an atom absorbs energy, the bond in the spectrum will appeal, where we have discussed this in very detail when basically we were discussing about the spectrum. All right, so here I don't think we should go with the explanation, since this is very easy. We're gonna have dark paints here, right? So which one is not true about cathode rays? We know that the mass of electron is 9.11 into 10 to the power minus 31 kg. So this is right? It casts shadows too when a pedal wheel is placed inside the discharge tube. Cannot ionize. Okay, I have a doubt on C. D, heat up. Yeah, we know that the cathode rays heat up. C, cannot ionized, but we know that cathode rays ionize, right? We have learned their ionization. So the right option here is cannot ionize. Cannot ionize. The fifth MCQ, a fast moving neutron can eject from nitrogen. What they are asking that what goes to the neutron, or how neutron is ejected, right? We need to tell that. So the correct option here is beta. These are very easy, right? So sixth MCQ, ionization energy of the elements of group 5A are greater than those of group 6A. The reason is that we need to identify the reason of it. Alright, so let's read the first option. Group 6A elements have greater shielding effect Okay, let's read the B option. What are they asking us in the B option? So group 5A elements half filled atomic orbitals. Okay. Third, group 5A element have electronegativity. Okay. D, group 5A elements have greater shielding effect. So our correct option here would be B1, which is group 5A elements have half filled orbitals. Alright, what are they asking us in the seventh MCQ? The relationship between energy of a photon of light and its frequency is given by. So let's read the options initially so that we can identify. Initially, let's read the statement again. The relationship between energy of a photon and light and its frequency is given by, wait, so let's read the MCQs now. So not MCQs, however, options. So de Broglie, dual nature of atom, Bohr's model, Planck's quantum theory, Rutherford. We have discussed each model in very detail. De Broglie hypothesis just says that electron can revolve. If light has a dual nature, then electron must have a dual nature as well. It can, behave as a wave as well if it is particle. And Bohr model we have discussed in very detail, which is only applicable for the mono electron species. All right, he basically told us the position and the speed of the electron at a time, and he calculated where will gonna electron spin, not spin, however revolve, where the angular momentum will be equal to nh by 2 pi, integral multiple of h by 2 pi. Planck's quantum theory tell us the relationship between the frequency and the photon of a light, right? And Rutherford, this is the solar system model. So here our correct option is Planck's quantum theory. Planck's quantum theory. All right. So 8th MCQ. Pressure in gas discharge tube was kept 10 torr, 1 torr, 0.1 torr, 0.01 torr. This is theory, right? So here the correct option is, of course, everyone knows, right? That is 0.01 torr. Wait for it. Okay, so we have 0.01 torr. Let's read the 9th MCQ. Positive rays give flash on silver nitrate plate, silver chloride plate, zinc oxide plate, zinc sulfide plate. When we were discussing about production of proton and electron, we have discussed the structure of the discharge tube as well. Alright, and we know that that entire tube was covered by a zinc sulfide. Right, so here the correct option is D, which is zinc sulfide. Right. 10th MCQ, the mass of neutron is dash times greater than the mass of electron. How many times the mass of neutron is greater than the mass of electron? So 540, 1840, 1480, 2000. We have already discussed that the mass of neutron is 18, or you can say the mass of proton is 1836 times greater than mass of electron, but the mass of neutron is greater than electron how many times? 1840 times. And if they would have asked us here proton, if they would have written proton here instead of neutron, so the answer must be 1836, right? For now answer is 1840 since they have asked us about neutron, right? So Millikan determined the charge on electron in oil drop experiment. Its value is 6.625 into 10 to the power minus 14, which is wrong. Of course, we know that this is not the charge of an electron. 1.602 into 10 to the power minus 23 coulomb. No, of course, this is not. 1.602 into 10 to the power minus 23 coulomb. No, of course, this is not 2. 1.602 into 10 to the power minus 19 coulomb. This is the correct option, right? So our correct option here is 1.602 into 10 to the power minus 19 coulomb, right? So 12, Planck's theory says energy is emitted. How energy is emitted? they basically ask us, right? So in continuous manner, discontinuous manner, simultaneously, never emit energy. This we have discussed when we were discussing about Planck's quantum theory, and that was in discontinuous manner, right? How? Let me make it, right? It was like this. Wait, let's make this with this color. It was like this. Not this, however, there were some gaps in bit, right? So it was like this. There were some gaps. That's why it was known as discontinuous manner, right? So this was the discontinuous manner. Now 13th MCQ, which of the following is not charged particle? So we need to tell that which one of the following is not a charged particle. Options are given, right? What options are given? Electron, proton, neutron, hydrogen nucleus. So electron is a charged particle, it has negative charge. Proton is a charged particle as well, it has a positive charge. Neutron is neutral particle, and they have asked us about charged particle. Or neutron has no any charge. So here of course the correct option is neutron, since hydrogen nucleus, which means there is one proton and one proton has positive charge, so hydrogen nucleus is the charged particle as well. Now 14th MCQ, which is the last MCQ for today. When atom is in the ground state, the electron is present nearest to the nucleus, nearest to the valence shell, in the second shell, in the nucleus. See, electron cannot be present in the nucleus, right? It cannot be in the second shell as well, since they are asking it is in the ground state, which means it is in the first shell. Alright, B, nearest to the valence shell. Valence shell means the last shell, and last to it means second last shell, right? But they are asking in ground state, so nearest to the nucleus, because right after nucleus we have, you know what, the first shell. So electron must be in ground state, which means first shell. Alright, so in today's video, what we have discussed, we have basically done, you know what, the MCQs from Ecat book, Smart Brains, right? Today we have solved only 14 MCQs, but yeah, in next video we're gonna try to solve more MCQs, and we will be completing the MCQs from the Ecat book as well. So bye bye for today.